And before we go to my favorite piece from the book, Peter, could you just try and explain in a sentence or two that we who do not know a lot about physics know what it was that really interested you? Where did you do your research? Where did you bring new light to that field of science? Just so we can honor you for that here.
Well, the honors was like coming. You have to remember that at first at Rutgers they were going to fire me. So let me put that in some context here. There were ups and downs with greater swings from one to the other than you might want me to talk about.
Well, that's part of the bumps in the road. We want everybody to be comfortable with that.
Certainly emphasize the fact that some people go in a straight line from somewhere to a glorious end. That's not the way it worked for me. There were lots of ups and downs, and they were sometimes tough and also enriching in many ways. And what interests me most as I think back to that time is that I saw myself as a bridge between the research community and that of first the high school teachers and in general the teaching community. I started some research in low temperature physics. I had heard about Bernie Serin, whose name is now on the physics building. It is named for him. And I had heard about his work in superconductivity, so that when I started, I went to him, got to know him a little bit, and then said, "Can I work in your laboratory?" And he said, "No, I'm not going to continue in superconductivity. There's nothing left to do." Well, that was a very poor prognosis. That's not the way it worked out. It is still a subject that gives rise to surprises and applications that have engaged many industrial and university physicists. But that's where I started, because after he said no, he did in fact find a corner for me, and I set up some experiments. And in particular, I started work on thermal conduction. Now, the only thing I want to mention about that is that it's regarded as an old-fashioned subject. There was no electronics. There were no fancy pieces of machinery. There were resistances and, rather simple tabletop material. And I was rather pleased about that, since I just come from what at that time was the world's largest cyclotron at Columbia. And the work, what I liked about it is that I took this rather old-fashioned looking subject and was able to make something of it. Use the thermal conduction not to find out how much heat was conducted along a piece of material, but rather to probe what was happening between the electrons and the lattice vibrations. And I'm talking about the lattice of atoms which make up the material, that could illuminate the structure. It turned out very quickly that I learned that the thermal conduction, just as is true for the electrical conduction, depends primarily on defects, either impurities or changes in the lattice structure from a regular arrangement. So that these experiments allowed themselves to be used as probes of what was going on a microscopic scale.